Welcome back to Information 365. In this video we are discussing Hubble Spot's ultra-speedy jet blasting from star crash. Make sure to like the video, subscribe the channel and hit the bell icon. Neutron stars are the trash-compacted surviving cores of massive exploding stars. They would fit inside New York City despite weighing more than our Sun. 1 teaspoon of surface material would weigh at least 4 billion tons on Earth at this unimaginable density. If that doesn't blow your mind, consider what happens when two of these cannonballs collide head-on. They cause ripples in the fabric of time and space, a phenomenon known as gravitational waves, which can be detected by ground-based detectors. The GW-170,817 explosive event occurred in August of 2017. The blast produced energy comparable to a supernova explosion. It was the first time gravitational waves and gamma radiation from a neutron star merger were detected together. Following the collision, a blast torch jet of radiation was ejected at nearly the speed of light, slamming into the material surrounding the obliterated pair. Only 2 days after the collision, Hubble was on the scene of the explosion. Hubble was used by astronomers to measure the motion of a blob of material that the jet collided with. The blob moved outward as the jet rocketed away from the explosion site, like a leaf caught in a stream of water from a garden hose. The incredible precision required to measure the blob's trajectory, obtained from Hubble and radio telescopes, was equivalent to measuring the diameter of a 12-inch diameter pizza placed on the Moon as seen from Earth. This was a major watershed in the ongoing investigation of neutron star collisions that keep ringing throughout the universe. Astronomers using NASA's Hubble Space Telescope made a one-of-a-kind measurement that indicates a jet was propelled through space at speeds faster than 99.97% the speed of light by a titanic collision between two neutron stars. The GW-170,817 explosive event occurred in August of 2017. The blast produced energy comparable to a supernova explosion. It was the first time gravitational waves and gamma radiation were detected simultaneously from a binary neutron star merger. This was a significant turning point in the ongoing investigation into these extraordinary collisions. In addition to the detection of gravitational waves, 70 observatories around the world and in space observed the aftermath of this merger across a broad swath of the electromagnetic spectrum. This marked a significant breakthrough in the emerging field of time domain and multi-messenger astrophysics, which studies the universe as it changes over time using multiple messengers such as light and gravitational waves. Just 2 days later, scientists directed Hubble to the site of the explosion. The neutron stars collided to form a black hole, whose powerful gravity began to draw matter toward it. This material spun rapidly, generating jets that moved outward from its poles. The roaring jet slammed into and swept up debris from the expanding shell of explosion debris. This included a material blob from which a jet emerged. For very long baseline interferometry, Hubble observations were combined with observations from multiple National Science Foundation radio telescopes working together, VLBI. The radio data was collected 75 and 230 days after the explosion. They were able to pinpoint the explosion site by combining the various observations. The Hubble measurement revealed that the jet was moving at 7 times the speed of light. According to radio observations, the jet decelerated to an apparent speed 4 times faster than the speed of light. Because nothing can travel faster than the speed of light, this superluminal motion is an illusion. Because the jet is approaching Earth at nearly the speed of light, the light it emits later has a shorter path to travel. Essentially, the jet is chasing its own light. In reality, more time has passed since the jet's light emission than the observer believes. This causes the object's velocity to be overestimated, appearing to exceed the speed of light. Thank you for watching the video.